Every AI you have ever used has the memory of goldfish. You tell it something and 2 conversations later it's gone. Today we fix that. I'm going to give you an agent real memory so it remembers what you told it yesterday, last week and across separate sessions. And once it does, it stops feeling like a tool and starts feeling like it actually knows you. That's what we are building, and I'll show you exactly how it works. No magic, just 3 kinds of memory and a retrieval trick. Let's go. Hey, Maneesh here. We have built an agent from scratch, given it tools and turned it into a team. But every one of those still forgets everything the moment a task ends. Today, memory, the thing that turns a clever demo into something that learns your context. If this is your first episode, the loop from episode 2 is the foundation. But you can follow the ideas here regardlessly. Here's the core problem. An LLM is a stateless. Every request starts from nothing. The only reason a chat remembers the earlier part of the conversation is the app resends the whole history every single time. The model itself remembers nothing. That works fine for one conversation, but 2 problems shows up fast. One, conversations get long and you can't resend everything forever. You'll blow up the past the context window and the cost. 2, the moment the session ends, it's all gone. New session, blank slate. Real memory means solving both, keeping what matters within a task and persisting what matters beyond it. There are 3 kinds of memory, and mixing them up is where people get confused. Let me separate them cleanly. Short-term memory, the current conversations, the message list we have used since episode 2, it lives only for this task. Long-term memory, which are facts that persist across tasks and sessions. For example, the user's name is Maneesh, he prefers Python, his project is called Agent Unpacked. Return to storage, load it back later. Third is semantic memory, a searchable store of past information you retrieve by meaning, not exact match. This is where your embeddings and retrievals comes in, the things people call it as RAG. Short term is a thing, long term is a file, semantic is a search engine over meaning. 3 tools, 3 jobs. Short term, you already have gone through it. It's the growing message list, the agent's working memory for the current task. Every turn appends to it. That's memory, that's scope to one task. The problem is it grows, long task, lots of tool calls, and that list balloons, which bring us to the wall everything hits. Every model has a context window, a maximum amount it can read at once, but not finite. And you pay for every token in it every turn. So a message list that grows forever is a problem twice over. Eventually it won't fit, and long before that it's expensive. So 2 fixes. 1, summarize. When the conversation gets long, have the model compress the older parts into a shorter summary and keep that instead of every message. 2, offload. Move facts you want to keep out of live conversation into long-term storage, then pull them back only when it is relevant. The second one is the real unlock, so let's build it. Long-term memory is simpler than people expect. Give the agent 2 tools, one to save a memory, one to recall memory, watch. So save memory writes a fact to a JSON file on disk with the timestamp and its embedding. Retrieve memory reads the store back and stores it against a query. At the start of every turn, we retrieve the agent's most relevant memories and load them into context. During the conversation, if it learns something worth keeping, your name, a preference, a decision, it calls save memory. Next session, those facts load right back in. That's it. Persistence is just write to disk, read from disk. The agent decides what's worth saving, and notice this is the same tool pattern from episode 3. Memory is just tools that read and write a store. Now the powerful one, long-term memory as a flat file works until you have hundreds of memories. Then you can't load them all, and exact match search misses things. What did I say about the database? Won't match a memory that says the Postgres setup. Same meaning, different words. The fix is embeddings, and an embedding turns a piece of text into list of numbers or vectors that captures its meaning. Text with similar message get similar vectors, even with totally different words. Store every memory as a vector. When you need to recall, embed the question and find the memories whose vectors are closest. That's semantic search That's the core of RAG, that we call it as retrieval augmented generation. Database and Postgres setup land near each other in vector space, so the question finds the memory even though the words don't match. That's the magic, and it's just distance between the vectors. Let's build a tiny version. We'll embed each memory, store the vectors, and on retrieval find the closest one by cosine similarity. No heavy vectors, just enough to understand it. In production, we'd use a real vector store, but the mechanism is identical. Embed the vector, compare against every stored memory vector, sort by similarity, return the top few. Those get injected to agent's context, so it can answer using write pass information. You just build the core of every chat with your docs product. Now let's go ahead with the code implementation. So just before that, before we deep dive, just wanted everyone to know that we have three kinds of agentic memory that we're talking today: short-term memory, the message list, the long-term memory, which we are going to store for longer term, semantic memory for predominantly semantic or similarity search based retrieval techniques. So going ahead, if you see, the first is we have just defaulted default trees that you'll see in our terminal to be used. That is what the first set of items are going to be used in the case. The second is on the memory store. This is for our long term plus semantic. So the load store is going to load our respective memory file. Save store is going to store our respective store of the memory file, and the function, the save memory, basically is it going to save the respective memory as part of durable with the timestamp and its vector. And retrieve memories is nothing but your retrieval that we generally do as part of your RAG. So we would have gone ahead, created embeddings already in store, and based on the similarity threshold that we have defined, it is going to retrieve the respective chunks for us. And list memories is going to list all the backfill memories, and forget is going to delete the single by ID those memories. So these are the functions that are core that we have written, and forget all is to delete everything from the day one. So this is the part 2 of it. The tool 3, so the part 3 talks about the tools the agent can call to manage its own memory, the same memory and recall basically. So save is going to save a durable fact worth remembering across sessions, and recall is going to search memory for anything related to a topic or a question. And in case if any of those are going to be called, it is going to call these respective functions that we had defined. In the fourth part is the agent loop, where we are going to iterate through based on the tokens that we have defined, and it's going to append on multi-turn based conversations as part of it. And do check that we have configured based on the max steps over here to have a maximum number of iterations that we want to devise. And now running of the agent, basically here it returns your answer and messages, and it so the caller should hold on to messages to pass back into next turn for the same iterations. And this is your system prompt that you can see over here. So that is going to be used across, and you can see all those retrieval of those informations in this case, and you're going to append all your conversations over here as part of it to remember those respective things. Now as part of demo, we have just used two set of sessions. The first session is I would pass this context on my name and the component, and the second part is going to be on the asking about my project. So let's simply run. Okay, so you can see the output. It is saving the respective memory. It has saved the memory, and now session 2 it is going to load, and now it is able to recall the respective information. So yes, this is a tiny bit of information. We will see it render it on the UI as well to get more context. Now as part of the demo to run it from front end and back end. So back end we're using FastAPI, front end we're using React. So go ahead and open up new terminal. We will first ensure that you are into respective folder for backend. So yep, and then you activate my virtual environment is already activated. So I'm not going to activate it. In case if you have not, so you can use your Mac or Python based activate command, and then just run a uvcon command for your FastAPI to run your respective backend for the port 8000 over here. So this would basically keep your backend running over here, and now you need to create another terminal to initiate your front end as well. So let me just go ahead into front end and do an npm install. So you'll find all these informations in your readme as well. You can follow the same, and in case if you have any issues, do let me know in the comments and we will take it up. Okay, so now if you can see this, my UI is running on localhost 5173 and my backend was already running on port 8000. So if I just open this link, we'll go ahead and see that now. Now the moment. I've got a browser UI running, a real chat, a memory panel on the side and a new session button. I'll use the sample message picker here. So I'm not typing live. Pick teach name plus hobby plus project, which fills in. Hi, my name is Maneesh. I love hiking and my project is called Agent Unpacked. That button does exact one thing. It clears the visible chat and starts a new brand message list. Watch, the memory panel didn't change. Those facts are still sitting on disk. And there it is. Memory chips lights up the above reply showing exact which facts got retrieved, and the answer is complete and correct. It never saw any of this in the current conversation. It remembered across a clean session boundary, and you can watch the retrieval happen in real time instead of trusting it blindly. That's the difference between a chatbot and something that actually knows your context. Let us try with any text stack, writing any series over here, and you can see that it is going ahead and showing all those components and saving all those respective informations for me over here. And you can also see all those respective session histories over here. So I've used OpenAI for all my respective information invocation, and I want to, let's say, mention about my project called, so it will get all those contexts. As you can see, all these are respective contexts that you have, and it is able to fetch these informations from those contexts, and yes, it will get me all the respective informations I want to explore. And you can go ahead and give any message, type in any information, and it will help me answer that. So this is just to render your respective UI as well, while you have been running internally the same functions that we have written over there internally hooked up with React to be precise. So try this out from your side and let me know how do you find it. The part people skip: memory fails in specific way. 1. Memory bloat. Save everything and store fills with noise. Retrieval gets worse, not better. The fix is be selective, save decisions and durable facts and not every message. 2 is stale memory. You saved user prefers Python a year ago, now it's wrong. Fix the timestamps and let the new memories override the old ones. Third is bad retrieval. The wrong memories come back and the agent answers using irrelevant context. Fix is to tune how many you retrieve and set a similarity threshold so weak matches doesn't get injected. 4 is the poison memory. A prompt injection convinces the agent to save something false or harmful and it resurfaces later. Fix is to treat memory as untrust input. Validate what gets saved, never blindly execute what memory says. Here's the judgment call, and it matters more than the code. Just because you can remember everything, that doesn't mean you should. Remember durable facts, stale preferences, decision, context that makes future help better. Forget or never store sensitive personal data you don't need. Anything the user would be uncomfortable seeing resurface, one off details with no future value. An agent that remembers everything isn't a feature, it's a liability. The good ones remember what's useful and let the rest go. And if you're building this for other people, memory is data. Treat it with privacy and consent that any stored user data demands. That's not a footnote, it's the responsibility core of building memory. Two practical realities: cost. Every memory you load into context is tokens you pay for each turn. Retrieval keeps that in check. Load the few relevant memories, not the whole store. Privacy: persisted memory is stored under data, where it lives, who can read it, how it's deleted. Those are real questions the moment this leaves your laptop. Build the delete path from day one. So that's memory: short term, long term, semantic, embeddings and retrieval, the real mechanism behind RAG, remembering across sessions, the failure modes, and the responsible take on what to keep. You now have an agent that learns your context and carries it forwards. That's the piece that make agent feel personal instead of disposable. Next episode, episode 6, would be the foundation of the end that we have been building, is around guardrails and safety. How to keep a capable tool using remembering agent from doing something you will regret. The most important episode, saved for what you can appreciate why. And also I mentioned my book regarding on memory and RAG in production, on vector stores, chunking, governance. Link is in the description. Leave a review if you want to grab it. Let me know your feedback, and do not forget to subscribe and like to get more content. I'll see you in episode 6. Till then, thank you.